Hey guys, today we're going to be doing constant rate of change with graphs. So this relates very closely to what we did yesterday about tables. And you're actually going to see tables in today's notes as well, since we've already been practicing what to do with tables. So example 1 says, the graph represents the amount of cheese a chef needs and the number of pizzas being made. Determine the constant rate of change by writing the information given from the graph into a table. Okay, so remember when we are in a graph, it tells you that this side over here is our y, and this side over here is our x, and it gives those two for you. So when we do our tables, this is going to be our x, that's going to be our y. So we're going to take our label and write our labels in here. So this is number of pizzas, and this is going to be cheese, okay, in ounces. So we only have 2 points here on our graph, but if I follow, you see that they plotted the points that hit exactly. So if I follow this pattern down, it'll hit one here, and it'll also hit one here at 0, 0. So now we have our 4 points we need for our table. So you always want to put your table points in order. So I start at 0, 0. Then I go over to 1, and it traveled up to 8. My next point is at 2, 16, and then we do 3 and 24. Okay, so when you have your points here, we can find our rate of change in our table to help us be able to represent what our equation is going to be. So if we find the rate of change, remember it's change of y over change of x. So let's find our changes. So from here to here, I add 8. I add 8, I add 8. So my rate of change for y is 8. My x's, I add 1 each time. So my rate of change is 1, and 8 over 1 is just 8. So my equation then is y equals 8x, because remember, whatever our rate of change is, that automatically connects to the x in our equation, and it always starts with y equals. So if you look here, there's an arrow right here, and it says, where is this change represented on the graph? So if I'm going from y to y, if these are my y's over here, what you do is take 2 points. So if I take these 2 points that they gave us here, this is called rise and run, okay? So my rise is my y, and my run is going to be my x. And what that means is we're going to be traveling from one point to another. So I would rise up from this point, and then I would run to the right to be able to hit that second point. Okay, and you're going to see me refer to rise over run a little bit later. So let's come over here to this side little box that says the point 0, 0 represent. So now we are relating it to actual items in our graph, so the labels. So it represents that 0 pizzas has 0 ounces of cheese, because remember our y is our cheese in ounces. So then the 0.34, again, this is x and that's y. So our represents that 3 pizzas has 24 ounces of cheese. Okay, so again, using a graph to be able to build the table, which we are familiar with, to then build an equation and be able to interpret what those pieces mean. Okay, so in the middle it says if a line goes through 0, 0, then the relationship is, this is a review from yesterday, it should be proportional. And if the relationship is proportional, then the constant rate of change is also called the constant of proportionality. Okay, so far we've got rate of change, we've used change of y over change of x, you just heard about rise over run, and now we're adding a fourth one in, which is constant of proportionality. And that means that it is going to be the k, and we find the k by doing the y over the x, which is the change of y over change of x. So this is going to be your k. This is the 8 that we just did in that example up there in our equation. because the 8 was the rate of change. So let's go to our next example. It says example 2. The graph shows the cost versus the number of oranges purchased. So is this relationship proportional? So to know if it's proportional, remember it goes through 0, 0. We come over here and we look at 0, 0 on our graph. Yes, it does go through 0, 0. So therefore, yes, it is proportional. How do you know? Because the line goes through 0, 0. Okay, and we're writing it as a point and parentheses for an ordered pair. Concept of proportionality. Okay, so we're going to first build a table, and we're going to build a table by finding some points on this graph. So we know that 0, 0 is going to be one of our points. Let's get our labels. So remember, this is your X, that's your Y. So my X label is going to be number of oranges. My Y label is going to be the cost. So let's plot some points. There is 0, 0. Okay, I only want to plot points where it meets directly on numbers in the grid. So I could plot one here. I could plot one here and here. Those are the only points that it hits exactly on the line. So I'm going to use those points to build my table. So I have 0, 0. Then I have 3 in the X, and it hits at 1 on the Y. And then let's do 6 on the X and 2 on the Y. And if it had more space, we could do 9 and 3. Okay, so now we're going to find constant proportionality, but we're going to call it rise over run. Okay, so we're going to do the rise over the run. So to do that, you start at any point that's there. So if I start here at my 3, 1, I'm going to rise up until I hit even with where the line of that second point is. So I went from 1 to 2. So my change is a 1. Now I'm going to run. So I'm starting at 3 and I'm going to end at 6. So I run to the right. So because I was going up and right, both of my numbers are positive, and the change from 3 to 6 is a 3. So my rate of change, according to my graph, is a 1/3. So let's find the constant rate of change of our table and make sure that it's the same. So my changes of my Y's over change of X. So my Y's are a +1, +3. So change of Y is 1, change of X is 3. So what do you notice? Well, it's the same as rise over run. And you are going to hear me start using these interchangeably. So I'll say one, I'll say the other, I'll do another one. So what information can we use to write the equation for this relationship? Well, if both of my rate of changes are 1/3, also called rise over run, also called constant of proportionality, also called K, then we know that we're going to take that 1/3 and we're going to connect it to my X in my equation. So my equation becomes Y equals 1/3 X. Okay, so let's look at our last example. The table in the graph below show the cost to rent a bicycle at 2 different stores. Which store charges more per hour? Okay, so now we're going to be comparing a table to a graph. Okay, so let's start by finding our rate of change for our table. So my change here is a +12 on both, a +1 on both. So change of Y over change of X is 12 over 1, which is 12. Okay, so that means that the hourly cost is $12 per hour. It wants to know if it's proportional. So whenever you have a table like we've done before, you can back it up to see if our table will go through 0, 0. So if I subtract 12, that gets me a 12 from 24. If I subtract 1, that gets me a 1. If I do it again, I subtract another 12. That's going to get me 0. If I subtract another 1, that's going to get me 0. So 0, 0 could show up in this table. So yes, it is proportional. So let's come over here to our graph. So I have 2 points. So I'm starting at 8 and I'm ending at 16, so I'm going to rise. So my rise is 8, and now I'm going to run. So I'm running from 1, and it looks like I end up at 2. So from 1 to 2, that is a change of 1. You have to pay attention to your scales on the bottom. You can't just count boxes. So I know that that's 8. So the hourly cost of Super Cycles is $8 per hour. So is this proportional? So to know if it's proportional, we look at 0, 0, which is here. The line does go through 0, 0. So yes, it is proportional. So now we go back and we answer the question. It wants to know which company charges more per hour and how we know. Well, I have $12. Sorry, guys. And I've got $8. So the $12 wins. So that is Pedal Rentals. And I'm going to say they charge $4 more per hour. And I know that from taking 12 and subtracting the 8, and that's going to get me my 4. Okay? So make sure if you have any questions about this, you come tomorrow prepared so that I can answer them. Have a good day.